Roku channels are designed to optimize the playback experience for users. The goal is to get users to content as fast as possible. When a user tells their Roku device to play a movie or searches for a TV show, series, or other content, we must deep link into the requested content instead of just launching the channel. For example, when a movie is selected from Roku search, a deep link is used to launch the channel and play the film without any navigation. In addition, if the user has already started watching the movie, deep linking resumes playback right where they left off. In this lesson, you will learn how deep links are used to launch content directly into playback from Roku Search, Roku Voice, Roku home screen banner ads, and other content discovery features on the Roku platform. The playback experience required for the different types of content in your channel, how to program your channel application to accept and process deep links, and how to test deep links. In addition, you will learn how to accept and process deep links while your channel is already running, create bookmarks by storing the user's playback position in the device registry and your backend system, and deep link into the right episode in a TV series at the right time with smart bookmarks. On the web, a deep link is a hyperlink that routes you directly to a specific piece of content on a website rather than the site's homepage. Similarly, for Roku channels, a deep link takes you directly to content instead of just launching the channel's homepage. Deep links are sent to channels typically from content discovery features in the Roku platform. This includes Roku Search, Roku Voice, and targeted display ads on the Roku homepage. When content is selected from one of these features, the Roku OS gets the unique ID of the content and its media type, like movie or short-form video, from the feed and sends them to the channel. The channel uses the unique content ID to determine which item to play and the media type for how to launch the content. For example, if a deep link is received for a movie or short-form video, the channel directly plays the content. If a television series deep link is received, the channel plays whichever episode the user is at. If they've never watched the series before, the channel launches Season 1, Episode 1. Let's dive a little deeper into the required playback experiences for the different media types. For short-form videos and TV specials, deep links simply launch them directly into playback. For example, if I use Roku Search to find content and then select an item matching my query, it is played immediately. And the same behavior applies if I use Roku Voice. When I ask my Roku device to play content, the matching item is played right away. Movies behave similarly. They are launched directly into playback. Additionally, however, bookmarks are used to determine the playback position. Specifically, when a user stops watching a movie, the channel saves the current playback position in the device registry or the publisher's backend service. When the user resumes the content, the channel gets the playback position and continues playback at that spot. Saving bookmarks in the backend service is recommended so they can be accessed on all Roku devices linked to the same Roku user account. Saving bookmarks in the device registry limits their availability to just that device. Television series, which contain a set of related TV episodes that may be organized by season, have different behaviors based on whether the media type passed into the deep link is an episode, season, or a series. So the same television episode with the same unique content ID can have 3 different playback experiences based on the media type passed into the deep link. If the episode media type is passed into the deep link, that episode is launched directly into playback using bookmarks. The episode media type is typically sent in deep links from Roku Search after the user has drilled down to a specific episode by, for example, searching for an actor or director. If the season media type is passed into the deep link, the channel launches a content springboard that displays episodes organized by season. The episode corresponding to the content specified in the deep link is highlighted. The season media type is typically sent in deep links from Roku Search and Roku home screen banner ads. For the series media type, the deep link launches the most appropriate episode into direct playback using smart bookmarks. A smart bookmark determines the episode to be launched and the playback position based on the type of series, whether the user has previously watched the series, and whether they have completed the last watched episode. For example, if the user is in the middle of watching Season 2, Episode 3, that episode is launched at its bookmark position. If the user finished that episode, the next one in the series, Season 2, Episode 4, in our example, is launched. If the user has never watched the series, Season 1, Episode 1 is launched. For daily, weekly shows such as game shows, podcasts, or other content that does not need to be watched in chronological order, the most recent episode is launched. The series media type is typically passed into deep link requests from Roku Voice. In the next section, we'll program our channel to handle deep links and provide the required playback experiences for the different media types in our channel. Before doing any coding, it's worth reviewing the deep linking documentation. This includes the deep linking implementation guide and the deep linking certification requirements, which specify that public channels must support deep linking with the required playback experiences and handle deep links while already running but without relaunching. The resources section has links to both of these documents. We are now ready to integrate deep linking in our channel. This will require us to update a number of files to accept and process deep linking parameters, pass the deep link content to the various screens, and create bookmarks in the device registry and retrieve them. As we always do, let's start by cloning the previous example. So let's copy the subscriptions example, paste it, and rename it deep linking. Now from your text editor or IDE, let's open the main BrightScript file. So let's open the deep linking folder and then the source folder and open the main BrightScript file. So the first thing we need to do is to enable our channel to receive deep linking parameters. So we're going to add an args parameter to the main method. When Roku Search, Roku Voice, or Testing Tools deep link into content, a launch command is sent to the channel along with an associative array that contains the content ID and media type. The args parameter contains this associative array. Next, let's add the args associative array received by the main method into calls to the show channel RSG screen method. And then let's update the show channel RSG screen method definition to accept the args associative array. Now let's scroll down to the screen show method, which launches the main scene, and insert code that stores the args associative array in the main scene's launch args field that will add to its interface next. Next, let's create an RO input object and store it in a reference variable named input object. An RO input object is used to receive events sent from a network client via the External Control Protocol, or ECP, which we'll describe later when we discuss testing deep links. We need an RO input object to handle deep links in case the channel is already running. If the channel is already running, we must deep link to the content without relaunching the channel. This is the required behavior in order to publish your channel to the Roku Channel Store. So let's set the message port of our RO input object to the one m.port object that we already created. In our while loop, let's add a print debugging statement that outputs the event type received by the message port. We can use this to see when the channel receives RO input events. And then we want to add logic for checking whether the message port received an RO input event. And if so, call the getInfo method to get the content ID and media type included in the associative array passed into the RO input event, and store the associative array in an input data variable. And we'll add a print debugging statement that indicates we're handling input received by the channel. Now next, let's use the associative array's doesExist method to verify that input data has both media type and content ID fields. And if so, create a new associative array named deeplink and set its content ID and media type fields to those stored in input data. And then let's set main scene's input args field, which we'll add to the interface next, to the deep link associative array. Alright, we're done updating the main BrightScript file so it can receive deep links. Let's save the file. Now, before we update the interface of the main scene component, we have to update our channel manifest to support the RO input event handling we just added to the channel. So, in the root deep linking folder, let's open the manifest file and enable the supports input launch attribute. This lets the Roku OS know that our channel handles RO input events. And that's it. Let's save the manifest. Okay, now let's create the deep linking logic BrightScript file. This file takes the deep link parameters passed into the channel, initiates playback of the specified content, and handles navigation between the video player, the detail screen that it builds for the deep link content, and the grid screen. So, open a new file in your text editor or IDE and create a getSupportedMediaTypes method. This method returns an associative array with the different media types in our channel. This includes the series media type and its associated seasons and episodes, movies, and short-form videos. Next, let's create the onInput deep linking method, which is called when the channel receives an RO input event with a deep link. When this happens, the observer event is passed into the method. And then we use the eventGetData method to get the associative array with the deep linking parameters and store it in an args variable. Let's make sure the args associative array is not invalid and verify that the content ID and media type parameters in it are. We'll do that by passing the args associative array into a call to the validate deep link method, which we'll create next. If both conditions are true, let's call the deep link method, which we'll create in a bit. This method takes the current video stored in the grid screen's content node, the content ID field, and the media type field in the args associative array. Now let's create the validate deep link method, which verifies that the media type and content ID passed into the onInput deep linking method are valid. This method takes the args associative array and stores the args.mediatype field in a media type variable, the args.contentID field in a content ID variable. It then calls the getSupportedTypes method and stores the result in a types boolean. It then verifies that the values stored in the media type, content ID, and types variables are not invalid and returns the result as a boolean. Next up is the deep link method, which takes the current video stored in the grid screen's content node, the content ID field, and the media type field in the args associative array. Let's pass the content node with a row containing the deep link content and the content ID into the findByNodeID method, which finds the content item when the row of video is passed into the method using the content ID. We'll store the content node for the deep link content item returned by this method in a playable item reference variable. Then let's call the getSupportedTypes method and store the result in a types boolean, and then verify that the deep link content item stored in the playable item content node is not invalid, and check that the media type of the content item is supported by the channel. If both conditions are true, let's call the clear screen stack method to remove all the screens from the screen stack except for the grid screen, and then call the appropriate handle media type method based on the media type of the content. So if the media type is an episode, short form video, or movie, we'll pass the playable item variable into the handle playable media types method. If the media type is a season, we'll pass the playable item variable into the handle season media types method. And finally, if the media type is a series, we'll pass the playable item variable into the handle series media types method. And we're done with this method. Next, we'll create the 3 handle media type methods that we just called, starting with the handle season media types method. This method takes the episode content item, and then we get the num episodes field from the episode stored in an item index field. This indicates where in the series playlist the deep link content is located. And then we get the episode series by calling its getParent method and its parent season's getParent method. It stores the return series in a series variable. And finally, we pass the series and item index fields into the showEpisodeScreen method, which opens with a selected episode highlighted. And then we'll monitor the visible field and call the onDeepLinkDetailScreenVisibilityChange method when the user presses back from the detail screen of the deep link content to return to the grid screen. The next method we'll create is handle playable media types. This method launches a deep link movie, episode, or short form video directly into playback. It takes the content node of the deep link video passed into it. Let's pass the content node into a call to the prepare detail screen method, which we'll create in a moment. This method creates the detail screen for the deep link content and pushes it onto the screen stack. When the video has completed playback, or the back button is pressed on the Roku remote control, the detail screen for the video opens. And then let's pass the content node into the check subscription and start playback method, which verifies that we have a valid subscription for the selected content and then launches it into playback. The last handle media type method we need to create is the handle series media type one. This method uses smart bookmarks to play an episode in the series. The episode to be launched into playback depends on the user's watch history with the series. It takes the content node of the deep link video passed into it. First, let's create an empty children array, and now let's use the series getChildren method to get all the seasons in it, and then iterate through each season. We'll pass them into the cloneChildren method and append the episodes returned by the method into the children array. Now we'll create a content node and store it in a node variable, and we'll use this node to contain all the episodes in the series. Now let's take the unique ID of the series node passed into the method and store it in the ID field of the node variable we just created. And then use the node's update method to map the episodes in the children array into the node's children field. And then we'll call the master channel smart bookmarks method to return the smart bookmark for the series and store that in the smart bookmarks variable, and pass the content node for the series into the get smart bookmark for series method and store the returned episode ID in the episode ID field. This is the ID for the last episode that was played in the series. Now let's set an index variable to 0 by default. We'll use this default value to play Season 1, Episode 1 in case there's no bookmarked episode for this series. Next, let's confirm that the episode ID is not invalid, and if so, use the find node by ID method to find the episode to be played from the playlist stored in the series content node. We'll use the episode ID to find the episode in the series and store it in an episode variable. And then set the index to the episode's num episodes field, which represents the episode's number within the series. For example, episode 1 in season 2. Now let's pass the episode to be played into a call to the prepare detail screen method to get its detail screen ready. We'll pass the index variable into the serial node's getChild method to identify the episode to be shown in the detail screen. And finally, pass the series node, the index of the episode to be played, and the isSeries flag, which is set to true, into the check subscription and start playback method. This method verifies that we have a valid subscription and then launches the episode into playback. Now let's create the prepare detail screen method. As previously mentioned, this method creates the detail screen for the deep link content and pushes it onto the screen stack. When the user navigates away from the video player, the detail screen for the video opens. It takes a content node representing the video. So first, let's create an instance of the detail screen component and store it in an m.deepLinkDetailScreen reference variable. And set its content field to the content node for the deep link video that was passed into the method. Next, let's create a couple of observers. First, let's monitor the visible field and call the onDeepLinkDetailScreen visibility change method when the user presses back from the detail screen of the deep link content to return to the grid screen. And then monitor the button selected field and call the onDeepLinkDetailScreen button selected method when the play button is pressed on the detail screen of the deep link content. Finally, we'll call the add screen method to add the detail screen to the screen stack, but not display it. Okay, now let's create the two event handlers we just referenced. First, let's create the onDeepLinkDetailScreen visibility change method. This method takes an event, and then we use that event's getData method to get the visibility of the deep link content and store it in a flag named visible. Let's use the getROSJNodes method to get the screen that generated the event. Next, let's verify that the visible flag of the deep link content is false and its detail screen is not in the screen stack. We can pass the m.deepLinkDetailScreen variable into the isScreenInScreenStack method to check whether the detail screen is in the screen stack. If both conditions are true, let's get the content stored in the content field of the m.deepLinkDetail screen and store it in a content variable. Verify that it's not invalid, and if so, update the grid screen's jump to row item field. We'll use the row of content stored in the home row index field and the current item selected in the home item index field to update the grid screen with the deep link content, and then set the deep link detail screen to invalid. And this method is done. Let's create the last one for this file, which is on deep link detail screen visibility changed. This method takes an event, and we use the events get data method to get the index of the button that was selected and store it in a button index variable. And we'll use the getROSJNode method to get the screen that generated the event and store it in a details variable. And we'll pass the button index into the getChild method of the buttons on the details screen and store the name of that button in a button variable. Let's get the deep link content stored from the content field of m.deepLinkDetail screen and store it in a content variable, and then check whether the play button was pressed by seeing if the button ID is set to play, and if so, set the playback position to the beginning of the video by setting the bookmark position field of the content node to 0, and then finally call the check subscription and start playback method to launch the deep link content into playback from its detail screen. So we're done with this file. Let's save it in the UI logic folder and name it deeplinkinglogic.brs. Now let's work on updating the other files in the UI logic folder. Okay, so let's first start with the content task logic brightscript file. So let's open it and scroll down to the end of the onMain content loaded method. Before ending the function, let's take the deep linking parameters in the m.top.launch args associative array and store it in an args variable. Now let's make sure the args associative array is not invalid and verify that the content ID and media type parameters in it are. And of course, we do that by passing the args associative array into a call to the validate deep link method. And if both conditions are true, call the deep link method with the deep link content, media type, and content ID. And this file is done, so let's save it and open the screen stack logic file. So let's scroll down to the end of the close screen method. And let's insert an add screen function, which adds a screen to the stack. It takes a screen content node. Now let's pass the screen node into the m.top_append_child method to add the screen to the main scene. And finally, let's push the screen onto the screen stack. Now let's create a clear screen stack method, which removes all the screens from the stack. And check whether there's more than one screen in the stack, and if so, let's add the following logic that gets executed while there's still at least one screen in the stack. We'll remove the last screen in the stack using the screen stack's pop method and store the remove screen in a last variable. Then we'll check whether the remove screen is visible, and if so, set its visible flag to false to hide the screen. And then we'll pass the remove screen into the remove child method. Now, if there's only one screen in the stack, we'll call the screen stack array's peek method to get the current screen in the stack and set its visibility flag to false in order to hide it. Finally, let's add an isScreenInScreenStack method, which takes a screen content node and returns a flag indicating whether the screen is in the stack. So let's loop through the screens in the stack and pass the screen into the ROSJNode's isSameNode method to check whether a screen in the screen stack refers to the same screen passed into the method. And we'll store the result in a result flag. If a screen matches, this method returns true. If none of the screens match, it returns false. And that completes this function and the update to this file. So let's save it. Now the next UI logic file update is the episode screen logic brightscript file. So let's open it. And in this one, we just have a few small updates. In the show episode screen method signature, let's first change this from a sub to a function, as it will now create and return an episode screen. And then change the selected item parameter to item index and set it to 0 by default. Now let's scroll down to the line of code where we set the episode.content field, and let's change it so it's set to the content node passed into the method. And then set the episode screen's jump to item field to the item index, then return the episode screen, and we're done. So let's save this file and open the detail screen logic brightscript file. let's scroll down to the onButtonSelected method. After the line of code where we get the index of the selected button, let's pass the button index into the getChild method of the button's label list. This returns the content node for the button that was pressed, which we'll store in a button variable. We'll then check the ID of the button node instead of the index to see whether the play button was pressed, and do the same to check whether the See All Episodes button was pressed. We'll then call the showEpisodeScreen method with the child node of the currently focused series. And finally, for this method, we'll check whether the continue button was pressed and call the handlePlayButton method with the isResume flag, which we'll add to the method next, set to true. In the handlePlayButton method, let's update the method signature so it also takes an isResume flag, which is set to false by default. If this flag is set to true, we'll use smart bookmarks to determine the playback position to resume the content in a series. Now let's scroll down to the line of code where we create a content node and insert a line and set the node's ID field to the ID field of the item content variable. After the line of code where we call the node.update method, let's set an index variable to 0. Next, we'll check whether the isResume flag for a series is set to true, and if so, we'll call the master channel smart bookmarks method to get the episode to be played and its playback position, and store it in a smart bookmarks variable. Then we'll pass the selected item into the smart bookmarks getSmartBookmarkForSeries field, which returns the ID of the episode to be played. We'll store this episode ID in an episode ID variable. And if episode ID is not invalid or empty, we'll use the findNodeById method to find the episode to be played from the playlist stored in the series content node. We'll use the episode ID to find the episode in the series and store it in an episode variable. And then if the episode variable is not invalid, we'll set the index to the episode's numEpisodes field. Now, if the isResume flag is set to false, we'll set the episode reference variable to the selected content and set its bookmark position to 0 to start the video at the beginning. In the signature of the check subscription and start playback method, let's change the 0 to the index variable. And then if the isResume flag is set to false for a movie, short form video, or episode, we'll set the bookmark position of the selected video to 0 to start it at the beginning. And then let's add logic for the case where the selected index is invalid to set it to the first row of content and the first video in the row. And that's it. We're done updating this file. So let's save it and open the video player logic BrightScript file. Okay, scroll down to the onVideoScreenClose method where we return the focus to the detail screen and insert the following code to populate the detail screen with a deep linked content. Let's first verify that the m.deepLink detail screen is not valid, and if so, get the current deep link content in the video screen's node field and store it in a content variable. And if the video screen's m.isSeries flag is true, which means the deep linked content in the video screen is a series, then get the current deep linked content in the video player by passing the last index variable, which represents the last episode played, into the getChild method of the video player's content node, and store the episode in the content variable. If the deep linked content is not a series, we'll just keep the detail screen set to the last item played in the video player. Great, we're done updating the video player logic BrightScript file, so let's save it, and now let's work on the detail screen component. So in the components folder, let's go to the detail screen directory and open the XML file. First, let's add script elements for the bookmark logic and smart bookmark logic BrightScript files in the UI logic folder that we'll create towards the end of this section. Then add an event observer to the content field. We'll call the onContentChange event handler when this field gets updated. And in the interface, let's add a buttons content node and set its alias to buttons.content. This node contains the play and see all episodes buttons for the label list in the detail screen. We'll add a continue button to the label list when we update the detail screen's BrightScript file next. And that's it. Let's save this file, and now let's open the detail screen BrightScript file. First, let's change the signature of the setButtons method so it takes an object parameter that will name buttons instead of the buttons variable. And in the line of code where we push the button names onto the results array, let's add an associative array with an ID key and the lowercase name of the button, such as play, see all episodes, and continue, as the value. Next, let's create an onContentChange event handler that's called when the detail screen's content node gets updated. When this happens, the observer event is passed into the method, and then we use the events_getData method to get the current video playlist in the detail screen and store it in a content variable. Let's verify that the content is not invalid, and if so, check whether there is at least one video in the playlist by calling the content node's getChildCount method and making sure it's greater than 0. And then store the result in an m.isContentList boolean. And if the m.isContentList flag is false, then we'll pass the content reference variable into a call to the setDetailsContent method. And finally, we'll switch focus to the play button in the detail screen by enabling its setFocus method. Now let's update the signature of the setDetailsContent method so it takes an object parameter. And in this method, right after we set the title and release date labels for the content, let's create an array of strings named ButtonList and store a play string as the first element in it. We'll use this array to temporarily store the names of the buttons in the detail screen's buttons label list. Next, we'll check whether the media type for the content item passed into this method is a series. And if so, call the master channel smart bookmarks method to get the episode to be played and its playback position and store it in a smart bookmarks variable. And then we'll pass the selected item into the smart bookmarks get smart bookmark for series field, which returns the ID of the episode to be played. We'll store this episode ID in an episode ID variable. And if the episode ID is not invalid or empty, we'll use the findNodeByID method to find the episode to be played from the playlist stored in the series content node. We'll use the episode ID to find the episode in the series and store it in an episode variable. And then if the episode variable is not invalid, we'll pass it into a call to the getBookmarkForVideo method that is called by the master channel bookmarks method, which we'll create later when we implement bookmarking in our channel. This will find the bookmark for the episode in the device registry, which we'll store in the episode's bookmark position field. And then we'll push a continue string onto the button list array. And finally, for a series media type, we'll push a see all episode string onto the button list array. Now, if the media type for the content item passed in this method is a movie, short form video, or episode, we'll pass it into a call to the getBookmarkForVideo method to find the bookmark for the content in the device registry, and then we'll store it in the item's bookmark position field. Next, we'll check whether the content item has been completed by seeing if its bookmark position is greater than 0. If so, let's push a continue string onto the button list array. This provides a button in the detail screen that users can press to resume playback of content they've already started watching. In the setButtons method, let's pass in the button list array instead of the single play button. This will add the applicable buttons to the detail screen for the content item based upon its media type and bookmark position. Next, scroll down to the onItemFocusChange method, and right before the line of code where we get the metadata of the currently focused video, insert a line of code to verify that the detail screen has a content item before populating it by calling the getChildCount method on the m.top.content variable and making sure the count is greater than 0. Now go down to the onKeyEvent method, and in the line of code where we verify that the key that was pressed was the left one, let's also add a condition to verify that the content node contains a playlist of videos by checking whether the m.isContentList flag is true. And let's also do this for right key presses. Okay, we're done updating the detail screen. Let's save this file and let's move on to the player task, which contains our RAF implementation. So let's go to the tasks folder and open the player task BrightScript file. Let's start by updating the play content with adds method. And after the line of code where we set the value of the last index variable to the start index, let's create an empty items array. And now before we get all the child content nodes for the video stored in the content variables playlist, let's make sure it has content by calling its getChildCount method and making sure the count is greater than 0. And if the content playlist is empty, we'll set the items array to the current content item. Now let's scroll down to where we set the add server URL and call the master channel bookmarks method to get the bookmark for the content to be played and store it in a bookmarks variable, and then call the master channel smart bookmarks method to get a smart bookmarks for the content and store it in a smart bookmarks variable. Now let's move to where we set the next video to be played, and if the index of the next video to be played is greater than the originally selected video, let's set the bookmark position of the next video to be played to 0 in order to start it at the beginning. Let's scroll down to the end of the method where we set the CSAS stream to the stitch stream. And now let's check if the content is a series by verifying that the m.isSeries flag is true. And if so, update the bookmark of the current episode in the device registry by calling the smart bookmarks update smart bookmark for series method with the series ID and the episode's content ID. Right after the line of code where we render the stitch stream, let's check whether the videos in the playlist have been completed by seeing if the keep play flag is false. If the flag is false, then update the bookmark for the video to be played next in the device registry by calling the smart bookmarks update smart bookmark for series method with the item variable and the time of the stitch stream's current position. Now, if the keep play flag is true, then delete any bookmarks for the next video to be played by calling the smart bookmarks update smart bookmark for series method with the video's ID. Finally, if the last video played was not the one that was originally selected and the m.top.isSeries flag is true, delete the smart bookmark for this series by calling the smart bookmarks update smart bookmark for series method with the series ID. Okay, now that we're done with the player task BrightScript file, let's move on to the main loader task. So let's open the main loader task BrightScript file in the tasks folder. Alright, in the get content method, let's scroll down to the line of code where we make sure the content metadata in the JSON string is not invalid, and set a home row index variable to 0. We'll use this to track the row containing the content item. Then after we create the row's empty children array, let's set a home item index variable to 0. We'll use this to track the content item's position within its parent row. Now after we start parsing the videos in each category, we call the getSeasonData method. In addition to passing the seasons category, we'll pass 3 additional parameters: the home row index, the home item index, and the series ID. We'll update the signature of the getSeasonData method to match this in a bit. After we call the getItemData method to populate a content node for a video with its feed metadata, let's set the home row index field of the item data content node to the value stored in the home row index variable. And let's do the same for the home item index. After we're done pushing the item data content node onto its home row, let's increment the home item index. And after we're done pushing a row of content onto the root content variable, let's increment the home row index. Now let's scroll down to the getSeasonData method and update its signature so it takes those 3 additional parameters: an integer representing the home row index, another integer for the home item index, and the series ID, which is a string. And finally, after we update the media type of an episode data item, let's set the episode data item's home row index field to the value stored in the home row index variable. And let's do the same for the home item index and series. And we're done updating the main loader task, so let's save it and continue on to updating the video screen BrightScript file. So let's go to the components folder, and in the video screen directory, let's open the BrightScript file. Okay, at the end of the init function, let's insert an observer for the video screen's visible field. When it changes, we'll call the onVisibleChanged method. This method invalidates the video screen's content node if the video screen is closed, but the player task is still running. So now let's go create the onVisibleChanged method. This method takes an event observer, and we'll use the event's getData method to get the video screen's visibility and store it in a visible flag. If the visible flag is false and the m.playerTask component is not invalid, which means the video screen is closed but the player task is running, let's stop monitoring the player task state field and then set the player task control field to stop in order to close the video screen. Then we'll get the video node wrapper created by RAF by passing the index returned by the m.top.getChildCount method, and we'll store the video node wrapper in a RAF renderer reference variable. If the RAF renderer video node wrapper is not invalid, we'll call its getChild method to get the video node and store it in a video variable. Then we'll check whether the video node is not invalid and its lowercase id is content video, which is the ID of RAF's video player node. If both conditions are true, we'll set the video node's content node to invalid, which resets it, and then invalidate the RAF renderer. Now, if the video screen is open, let's invalidate the player task. Now, let's make a small update to the onIndexChange method. After the line of code where we set the player task's start task field to the index variable, let's set the player task's isSeries flag to the value stored in the m.top.isSeries variable. And finally, in the onPlayerTaskStateChange method, in the line of code that checks whether the video screen is done or has stopped, let's also verify that the player task is not invalid, and if both conditions are true, then invalidate the player task. Okay, we're done updating the video screen BrightScript file, so let's save it. And now we're going to move on to implementing our bookmarking functionality. Bookmarking is used to store the place in a video where the user stopped watching, which is referred to as the playback position. When a user continues watching the video, a channel can retrieve the playback position and resume playback at that spot. Bookmarks are required for content that is longer than 15 minutes. Bookmarks can either be stored locally in the registry of the Roku device or in the publisher's backend system. Storing the bookmarks in the backend is recommended because it makes them accessible to not only all of the user's Roku devices, but other platforms as well. For this example, we're going to use the device registry because our channel is not using a backend system. The device registry can be used to store small pieces of data like bookmarks on a Roku device. Channels can write data to a separate secure section in the device registry. This section cannot be accessed by channels from other developers. The maximum size of each channel's registry is 16K bytes. Therefore, channels need to minimize the amount of data stored and the frequency it is updated. So the first file we're going to update is the utils BrightScript file in the source folder. So let's start our bookmarking implementation by creating the find node by ID method. This method is used to get the content matching the content ID passed in deep linking parameters. It takes a content node that contains a set of child content nodes for the videos in the channel, which is a grid screen row in our case, and it takes the content ID included in the deep link request sent to the channel. Let's iterate through each child content node or element in the grid screen row, which we'll get by calling the getChildren function of the content passed into the find node by ID method. And we'll check whether the ID of the element matches the one passed into the find by node ID method. If so, we'll return that element. If there are no matches, which will happen in the case where the element is a series, we'll check whether the series element node contains any episodes by calling its getChildCount method and verifying that it's greater than 0. If there are episodes, we'll make a callback to the find node by ID method with the series element and the content ID. This will loop through the series and check if any episodes in it have the matching content ID. If there is a match, we'll store it in a result reference variable, and then we'll return this reference. Now, if there are no matches, this method will return invalid. Next, let's create the regRead method, which is the first of our 3 methods for managing bookmarks. It takes a registry key and a registry section, which is set to invalid by default, and it returns the value stored in the specified key. In our case, the value is the current playback position of a video. So first, let's check whether registry section was passed into the method. If not, the section will be set to invalid. In this case, we'll set the name of the device registry to be used to default. And then we'll create a new registry section. We do this by creating an RO registry section object with a name stored in the section attribute. And we save the registry section object in a reg reference variable. Now we'll call the registry section's exist method with a key that was passed into the regRead method to confirm that the provided key resides in the registry section. If the key exists, we'll pass it into the registry section's read method to get its associated value. And finally, we return invalid if the key passed into the regRead method does not exist. Next, let's create the regWrite method, which is used to save the user's playback position for a video in the device registry. It takes the name of the key and the value to be saved, and the registry section in which to store them, which is set to invalid by default. Just like we did for the regRead method, we'll first check whether registry section was passed into the method. If not, the section variable will be set to invalid. In this case, we'll set the name of the device registry to be used to default. And then we'll create a registry section. And like before, we do this by creating an RO registry section object with the name stored in the section attribute. And we save the registry section object in a reg reference variable. Now we'll call the registry section's write method with the key and value that was passed into the regWrite method. This stores the specified key value pair in the specified registry section. And finally, we call the registry section's flush method to save the key value pair to persistent storage. This method should always be called after doing one or more writes to the device registry. So the last thing we need to do is to create the regDelete method, which is used to remove a key value pair from the device registry. It takes the name of the key to be removed and the registry section in which it is saved, which is set to invalid by default. And this method is very similar to the regWrite method. Just like we did for the other two methods, we'll first check whether a registry section was passed into the method. If not, we'll set the name of the device registry to be used to default again. And then create a registry section, and like before, we do this by creating an RO registry section object with a name stored in the section attribute, and we save the registry section object in a reg reference variable. Now we'll call the registry section's delete method with a key that was passed into the regDelete method. This removes the specified key from the specified registry section. And finally, we call the registry section's flush method. Okay, we're done updating the utils BrightScript file, so let's save it. And now let's move on to creating the bookmarks logic BrightScript file, which contains our bookmarking functionality for movies, short-form videos, and TV episodes. So open a new file in your text editor or IDE and create the master channel bookmarks method, which functions as an object that contains the bookmarking methods that we previously called from the detail screen and player task files. In this method, let's create an associative array named this that contains key value pairs for the following methods. Load bookmarks, which reads and parses all the bookmarks in the device registry. Save bookmarks, which writes bookmarks to the device registry. Update bookmark for video, which updates the video passed into the method based on the specified playback position. And get bookmark for video, which retrieves the bookmarks from the device registry and returns the one for the video passed into the method. Remove bookmark for video, which deletes the bookmark for the video passed into the method from the device registry. And clear bookmarks, which removes all the bookmarks from the device registry. And then we'll return the this associative array. As you may have observed, we can call this method and store the result in a reference variable, and then use the reference variable to access these methods. Or we can just use method chaining. This construct enables us to call any of these methods from this file using an m.component variable. Next, let's create the load bookmark method to read and parse all the bookmarks in the device registry. To do this, we create an empty array with component access named m.bookmarks, and then call the regRead method in the utils file looking for the bookmarks key in the master channel bookmarks registry section. And let's save the value stored in the bookmarks key in a variable named raw. And if raw is not invalid, let's pass it in the parse.json method to transform the JSON string the bookmarks are stored in into an array of associative arrays. And then let's set the mBookmarks array to this array. Now let's move on to the save bookmarks method, which writes bookmarks to the device registry. To do this, we call the regWrite method with the bookmarks key, the m.bookmarks array containing the bookmarks to be saved, which we've transformed back into a JSON string, and the Master Challenge Bookmarks Registry section where the bookmarks will be stored. Next up is the Update Bookmark for Video method, which updates the playback position of the last video played. It takes a video object and the playback position, which is an integer. So let's first check whether the playback position passed into the method is invalid, or less than or equal to 0, or the video ID is invalid, or the video's media type is a series. If so, we'll immediately exit the method. Then we'll check whether the m.bookmarksArray is invalid, and if so, we'll call the loadBookmarks method using the m.component variable. Next, let's create a success flag and set it to false. We'll use this flag to track whether a video has an existing bookmark. Now, let's loop through each bookmark in the m.bookmarksArray and check whether the ID field of the bookmark is the same as the ID of the video passed into this method. And if so, update the bookmark's position field to the one passed into this method, and then set the success flag to true and exit the for loop as we've already found the matching bookmark for the video. Now, if the success flag is not true, which means there are no bookmarks for the video passed into this method, let's push an associative array with the video's ID and playback position onto the m.bookmarksArray. Finally, let's call the saveBookmarks method using the m.component variable to write the updated m.bookmarksArray to the device registry. Okay, moving on to the getBookmarkForVideo method, which returns the playback position for the video passed into the method. It takes a video object, and first let's set a result variable to 0. We'll use this to store the playback position of the video. Then we'll check whether the m.bookmarksArray is invalid, and if so, we'll call the m.loadBookmarks method. Now, let's loop through each bookmark in the m.bookmarksArray and check whether the ID field of the bookmark is the same as the ID of the video passed into this method. And if so, get the bookmark stored in the device registry for the video and set the result variable to that value. And then exit the for loop. Finally, we'll return the playback position stored in the result variable. Next is the removeBookmarkForVideo method, which deletes the bookmark for the video passed into the method from the device registry. It takes a video ID as a string, and the first thing we'll do is to check whether the m.bookmarksArray is invalid, and if so, call the m.loadBookmarks method. Then we'll loop through the m.bookmarksArray and check whether the ID field of the bookmark is the same as the ID of the video passed into this method. And if so, we'll call the delete method to remove the associative array with a bookmark from the m.bookmarksArray. And then we will exit the for loop. Finally, let's call the m.saveBookmarks method to write the updated m.bookmarksArray to the device registry. The last method in this file is clearBookmarks. This removes all the bookmarks from the device registry. It simply resets the m.bookmarksArray to an empty array and then calls the m.saveBookmarks method to write the cleared bookmarks to the device registry. And that's it for the bookmarks logic file. So let's save it in the UI logic folder and name it bookmarkslogic.brs. And now let's create a similar file for managing smart bookmarks for our series content. While bookmarks are used to track the playback position of content, smart bookmarks are used to track the last episode played in a series. So open a new file in your text editor or IDE and create the master channel smart bookmarks method, which functions as an object that contains the smart bookmarking methods that we previously called from the detail screen logic, deep linking logic, and player task BrightScript files. In this method, let's create an associative array named this that contains key value pairs for the following methods. Load smart bookmarks, which reads and parses all the smart bookmarks in the device registry. Save smart bookmarks, which writes smart bookmarks to the device registry. Update smart bookmark for series, which updates the smart bookmark for the specified series. Get smart bookmark for series, which retrieves the last episode played in the series. And remove smart bookmark for series, which deletes the smart bookmark if the user has finished the specified series. And then we'll return the this associative array. Next, let's create the load smart bookmarks method to read and parse all the smart bookmarks in the device registry. To do this, we create an empty array with a component access named m.smartBookmarks. and then call the regRead method in the utils file looking for the smart bookmarks key in the master channel bookmarks registry section. And let's save the value stored in the smart bookmarks key in a variable named raw. And if raw is not invalid, let's pass it in the parseJSON method to transform the JSON string the bookmarks are stored in into an array of associative arrays. And then let's set the m.smartBookmarks array to this array. Let's move on to the saveSmartBookmarks method, which writes smart bookmarks to the device registry. To do this, we call the regWrite method with the smart bookmarks key, the m.smartBookmarks array containing the smart bookmarks to be saved, which we've transformed back into a JSON string, and the master channel bookmarks registry section where the bookmarks will be stored. Next up is the update smart bookmark for series method, which updates the smart bookmark for the series passed into the method. So let's first check whether either the series or episode ID passed into this method is invalid, and if so, we'll immediately exit the method. Then we'll check whether the m.smartBookmarks array is invalid, and if so, we'll call the m.loadSmartBookmarks method. Next, let's create a success flag and set it to false. We'll use this flag to track whether an episode has an existing bookmark. Now let's loop through each bookmark in the m.smartBookmarks array and check whether the ID field of the bookmark is the same as the ID of the series passed into this method. And if so, update the bookmark's episode ID field to the one passed into this method, and then set the success flag to true, and then exit the for loop as we've already found the matching bookmark for the series. Now if the success flag is not true, which means there are no smart bookmarks for the series passed into this method, let's push an associative array with the series and episode IDs onto the m.smartBookmarks array. Finally, let's call the m.saveSmartBookmarks method to write the updated m.smartBookmarks array to the device registry. Okay, moving on to the getSmartBookmark for series method, which returns the last played episode for the series passed into the method. It takes a series ID as a string and returns a string with the episode ID. And first, let's set a result variable to an empty string. We'll use this to store the ID of the last played episode. Then we'll check whether the m.smartBookmarks array is invalid, and if so, we'll call the m.loadSmartBookmarks method. Now let's loop through each bookmark in the m.smartBookmarks array, and we'll check whether the ID field of the bookmark is the same as the ID of the series passed into this method. And if so, we'll get the bookmark stored in the device registry for the episode and set the result variable to that value. And then we'll exit the for loop. And then finally, we'll return the episode ID stored in the result variable. Finally, let's create the remove smart bookmark for series method, which deletes the smart bookmark for the series passed into the method if it has already been completed. It takes a series ID as a string. And the first thing we're going to do is check whether the m.smartBookmarks array is invalid, and if so, call the m.loadSmartBookmarks method. Then we loop through the m.smartBookmarks array and check whether the ID field of the smart bookmark is the same as the ID of the series passed into the method. And if so, call the delete method to remove the associative array with a bookmark from the m.smartBookmarks array and exit the for loop. Finally, let's call the m.saveSmartBookmarks method to write the updated m.smartBookmarks array to the device registry. And we're done with this file, so let's save it in the UI logic folder and name it smartbookmarkslogic.brs. And now all the logic for managing deep links and bookmarks is complete. Before we can test our channel, we need to make a quick update to the main scenes BrightScript file that's related to measuring channel performance. So in the components folder, let's open this file. So after we call the run content task method to load the grid screen with all the content from our feed, we need to send the app launch complete signal beacon. This enables us to measure how long it took for our channel to launch. Now the Roku OS automatically fires the corresponding app launch initiate beacon when the user presses OK to launch a channel. But we need to place the app launch complete beacon at the point where the channel is fully rendered and operational, which is the grid screen in our case. As mentioned in the debugging lesson, you can use the debug console to view the channel's launch time and other performance metrics measured by the signal beacons, such as the channel compilation, video launch, and channel exit times.
Measuring your channel's performance is important because it has to meet the metrics specified in the channel performance certification criteria in order to be certified and published to the Roku Channel Store. The certification criteria includes requirements for the channel and video launch times. For more information, review the channel performance certification criteria and check out the Measuring Channel Performance Guide for how to implement signal beacons in a channel. You can find both of these documents in the resources section. Okay, we're done updating the code in our channel. Let's save this file, and now we can sideload and test deep linking and bookmarking. Great, so now let's test the channel on your Roku device by sideloading it and then sending it deep link requests. So let's archive the contents in the deep linking folder and then use the development application installer to load it. To test the deep linking implementation we added to our channel, we need to send it deep link request via the External Control Protocol, or ECP. ECP is a RESTful API that enables a Roku device to be controlled over the internet. It is used by many test applications in the Roku platform. One of those tools is the Deep Linking Tester. It provides a simple UI for adding test devices, selecting the channel to be tested, creating test cases, entering the content ID and media type, and selecting the launch or input command to be sent. The result is an ECP command that sends a deep link request on port 8060 of the specified device via an HTTP post request. This launches the content specified by the content ID with a playback experience required by the media type. So let's use the deep linking tester on our channel. You can access this tool from the Roku Developer Tools page, and you can then also download it to your local machine. After you add your test device, let's select our channel. A side-loaded channel can easily be identified by its dev ID. If you're accessing the deep linking tester from the web, you'll need to manually add the channel by naming it and enter its dev ID. We can then add one or more test cases. Typically, you'll want to test both launch and input commands for each media type supported by your channel. Our channel includes 5 media types: short-form videos, movies, episodes, seasons, and series. So we'll have a total of 10 test cases. Let's name our first test case Input Short-Form Video. In the Content ID box, let's enter the ID for one of the short-form videos in our channel, which we'll get from the content feed. Specifically, you'll see that each video in the feed has an ID field. And then in the media type box, we'll select or enter short-form video. Once again, you can check the content feed for the media type for a specific piece of content. Finally, I'll select which command to send, launch or input. Launch is used for testing deep links when our channel is not open. Input is used when our channel is already running. Our channel includes logic for handling both scenarios. So we already launched our channel when we sideloaded it. So let's select input and test input commands on content with different media types. When I click send, the specified content is launched directly into playback, which is the required playback experience for short-form videos and movies. Also note that the channel was not relaunched when I sent the input command. We can create test cases for a movie in our content feed and see the same behavior. Now, if I select a series, it'll check the device registry for the last episode I watched and either resume that episode or launch the next one in the series if I finished. If we've never watched a video in this series, it will launch Season 1, Episode 1. And now if I select an episode in a series, and use the season media type, it will launch the episode screen with the episode and its season highlighted. And to finish our input test, if I select the same episode, but now use the episode's media type, it will launch the episode directly into playback using bookmarks. So let's exit our channel so we can test the launch commands. The good news is that I can use the same commands we created for testing input commands for testing the launch ones. So I'll just change the command from input to launch, and you'll see that the channel is launched and the playback experience required by the media type in the command is executed. Now, if I enter a content ID that doesn't exist or select a mismatching media type, for example, season for short-form video, the channel is just launched to the home screen. We've configured our channel so that it can handle an incorrect deep link command. Other behavior that your channel needs to handle includes validating unauthenticated users before being deep linked into your channel for the first time. In this case, you'll use the on-device authentication flow mentioned in the subscription lesson to authenticate the user before processing the deep link request. Also, if a purchase is required to access content, you can simply display a subscription dialog like we did in the previous lesson before letting the user view deep link content. Alright, one last thing we want to demonstrate before we're done testing, and that is that we can also send deep link requests via curl commands. So I'll open a terminal and create a post request without any data, and then enter the IP address of my Roku device, port 8060, which is the port that receives ECP commands, and in the URL path, let's include the launch or input command and the channel ID, which is dev. You can test deep linking on the production version of your channel by entering its unique channel ID, which is generated when you create your channel. And in the query string, now let's enter the content ID key and set it to the ID of the content to be launched. Enter the media type key and set it to the media type of the content. And then press enter and you'll see the specified content is launched with a playback experience based on the media type.
Thank you so much for watching this video. For more Roku developer videos, subscribe to our channel. And for the rest of the videos in this course, as well as additional demos and tutorials showing you how to develop on one of the world's leading streaming platforms, check out the link to the Roku Developers video site in the description below.